So to summarize the probability properties, the probability of an empty set is 0, or an empty event is 0, and we call that an impossible event. If we have the probability of getting something in the sample space, we have equal to 1. This is a certain event. For any event, the probability of that event is always between 0 and 1. It can equal 0 or 1, but it cannot be outside of that interval. If A and B are events and they're disjoint, meaning their overlap is empty, then the probability of their union is just the sum of the two probabilities. If they are not mutually exclusive events, if they are any events, then we have the probability of the union is the sum of the two probabilities minus the probability of the intersection. And if A is an event, then the probability of A is equal to 1 minus the probability of A complement. This should be A complement here. There we go. All right, so if we look at one last example for these properties, if we have a golf bag containing 2 red tees, 4 blue tees, and it should say 5 white tees, can't see it behind me, but 5 white tees, what's the probability of the event R that a T drawn at random is red? So the bag contains a total of 2 red, 4 blue, and 5 white tees, so 11 tees total. 2 of them are red, so the probability of drawing a red tee is 2/11. What would be the probability of getting a non-red tee? So we could think about this as the complement of the event R. So the event R had probability 2/11, so we can just subtract that probability from 1, and we know that the probability of getting a tee that's not red is 1 minus 2/11, or 9/11. What is the probability of the event that a tee drawn at random is either red or blue? These are mutually exclusive events. A tee cannot be both red and blue at the same time. So we can just add together the probabilities of getting a red, 2/11, and the probability of getting a blue, 4/11, to get 6/11 total. We can also think about probability geometrically. We can use a model that's an area model, and we can have areas proportionate to the probability of an event. So if we think about, for example, a geometric model for an experiment of tossing a fair coin, we could just draw a square and make sure it is split in half. An easy way to do this is to draw the diagonal. So this would geometrically represent the probability of tossing a fair coin. Rolling a fair die, we need to have 6 equal areas. So we could draw a hexagon and split it into 6 equal triangles, and this represents the probability of when you roll a fair die. That is the end of this lesson. Please reach out if you have any questions, and good luck. I'll see you soon.